In this video I'm gonna show you how you can implement a machine learning algorithm for robotics using Gazebo and ROS as a virtual robot. This example in this example will be used a super vector machine algorithm to classify traffic signals to make an autonomous robot. Okay, first of all, I want to give you some details of theory about super vector machine, or SVM for short. This is machine learning algorithms to solve classification and regression problem. For this figure, you can see this is a classification for two objects. As you can see, this is like the linear regression algorithm based in the line that separate two classes. But in super vector machine, we have to consider the dashed line. This is called super vector, and the algorithm have to calculate the distance, the optimal distance to have a optimal solution of the separation of the classes. No, this algorithm could be used for two classes, three classes, four classes, or more. This is called a multi-classes problem. Okay, now I'm gonna launch the simulation of the robot. You can see how the algorithm works. And finally, I will give you some information of the codes of the C++ code. First, the robot detects a turn signal, and the robot has to make some actions. This action is reorientates the orientation of the turbo robot. In this case, turn left. Second, the robot detects a forward signal, and the robot have to detect and move forward. Detect the second signal, and the robot make the action. In this case, move forward. Okay, the robot move forward. Okay. Finally, let me show you how the coding works in this simulation. The simulation is based in two nodes for ROS. One node is for the AI algorithm or super vector machine algorithm that classifies the three traffic signals. So the second is for the motion of the robot. That send the commands to move the robot and orientate the robot. First, the vision node. This vision node begins with with the instance of the classifier to begin with the training of the model. Subscribe for the robot turbo camera image, and publish the solve of the model. In this case, what kind of traffic signal was detected. Training stage begin with the training model of the super vector machine. This is here. First of all, load the images. This is the method of load image for each kind of traffic signal, forward, turns, stop signal. Okay. Next, use the HOG feature. This is the histogram oriented gradients to recognize the gradients of the matrices of the images. This is very important to have a good estimation of the training images for the model. Next, we have the training. This is here using these steps based of this SVM algorithm is based on OpenCV library. This is cool. This is very easy to use. That's all for training. After training, the node visions have to wait for the information of the camera. If there are communication, the robot can validate the image. After this node detect the camera image, begin with the noise method. This method then remove the noise of the image detected for the camera of the robot. After that, use the MSER feature. This is here. This is here. This here. This is this is a method to recognize the feature description of the images. In this case, the traffic signals. That is the key points that we need to detect and show in the figure. Next, we have to use the HOG feature again. Next, SVM testing. This is the prediction or validation of the model. Right? Predict the model based on the image detected. And after that, publish the message of the detection of this class and visualize in the computer. Okay, the second node is this one, Navic node. This node work with the topic CBC CMD BL moves input teleop to move the robot, linear and orientation. Okay, and the robot receives the information of the subscription of the AI model is based on this callback. This callback you can see here. Okay. Every signal that is detected of the model, the robot has to make the actions. If the action is action 1 of detect the forward, the robot has to make these actions, steps of actions, again for turn signal, also for the stop signal. Okay, for each signal detected, the robot makes different actions.